Topic 1.4 Composition of Mixtures. Quick review of pure substances. In the previous 1.3, we have already discussed the pure substances. Pure substance means only one kind of chemical species are present. Their composition is constant throughout the sample. If I take an example of atoms, so there are three types: atoms, molecules, and formula units. Pure means you're going to have pure helium, so it will be consisting of only helium atoms. If it is a pure sample of neon, you will have always the neon atoms. If you say water, you will have only H2O. If you say ionic compound, it is pure NaCl. So you will only have NaCl being repeated number of times. So all the species will be chemically identical. So pure substance means have identical composition and they will always follow a law of definite proportions. If you don't remember this, review 1.3, that will help you to give a good recap of pure substances. On the other hand, when you have mixtures, mixture means two or more different substances physically combined. If I take an example of salt water, if you are confused, visualize, take a suitable example and visualize the thing. So salt water means you will have salt and water mixed together. So salt is NaCl and water is H2O. So they are mixed with each other, but they have maintained their identity. Water is water, sodium chloride is sodium chloride. You have just mixed them and you can separate them easily. So they are different substances physically combined. Composition can vary. Suppose you have 1 tablespoon of NaCl and you have 1 liter of water. Absolutely fine. So their composition can vary. They retain their chemical identity. So sodium chloride will remain sodium chloride and they are not going to change the composition. And you can separate them by physical methods. Suppose I can do simple distillation to separate these two components. All right. So examples can be air, salt, water, soil. There are many more examples around you, which is an example of a mixture. Now, a comparison of pure substances and mixture. I think you are good at it. Pure substances will have fixed composition. Like water, there will be ratio of 1:8. That will stay the same always. So because it's a pure substance, and the mixture is variable. When I say mixture, you can have NaCl and water. So you will have 2 or more substances in a mixture, whereas in pure substance, you will have only one substance like water, carbon dioxide only. So you will not have another compound. Separation. If you need to separate a pure substance, that's a chemical change. But mixture can be separated physically. When I say physically, you can do filtration, you can do distillation. So these are some examples, all right? Then comes elemental analysis. Elemental analysis is a technique used to determine the composition of a substance. Suppose I have got a data and the data provides me the sample contains 40% of carbon, 6.7% hydrogen, 53.3% of oxygen. So it helps in measuring which substances are present, relative amount of each element. If you know about this, you can easily determine the empirical formula of the compound and you can also check the purity of the compound. Let's solve some question. I want you to pause the video and do the questions by yourself and then come and check. All right, let's check. A student performs elemental analysis on a compound containing nitrogen and oxygen. I have made them bold, but you will not be having in bold what is being given. You have to find out the important information for yourself. The analysis shows the compound contains nitrogen and oxygen and the percentages are given. Which of the following questions can be answered using this information? So you have percentage of compound. Relate. What is the empirical formula? Yes, not the molar mass, not the melting point, not the density, because we have done it. So just what you have learned, try to connect, when you make connections, it's a logical thinking. So a student measures the mass of a sample of magnesium metal. So he measures the mass of a sample. The metal is heated strongly in oxygen until it reacts completely to form MgO. So you have now the mass of MgO produced is measured. So you have mass of magnesium, you have mass of MgO. All right, so which of the following questions can be answered using the data from the experiment? What is the molar mass? No. What is the percentage composition? All right. Not the melting point, not the density. So answer gonna be B. Next question. A jar labeled CaCO3 contains a pure white powder. A student analyzes a sample and obtains the following data. So mass of the sample, the percentage of the compound is very important because it's an elemental analysis. You found out which element is present in how much amount. The density and the color. The color can be generic. There are so many compounds which are white in color, so they don't reveal all the information, maybe some of it. And then which piece of information is most useful in determining whether the powder is pure? So you are talking about the purity. For the purity, the mass, you cannot use the mass of the sample that's pure or impure. The percentage composition, this is a part of elemental analysis. If you know how much percentage of carbon or oxygen is present in that compound, most probably it's gonna give you the information about the compound, not the density nor the color. Yeah, so this is how we finished 1.4. Very simple, very easy, and practice more questions.